Welcome to Pratidhvani, where we try to humanize science. I'm your host, GV Pawan Kumar, and this is my solo podcast episode. And the episode title is Let Go the Ego, Some Lessons from History of Science. Let me tell you a story. In 1940s, a professor in America drives 100 miles in winter snow. He does this for a full semester to teach a class of two students, and this person's name is Subramaniam Chandrasekhar, the teacher's name, I mean to say. The two students who was teaching was Yang and Lee, and in 1957, the Nobel Prize in Physics went to parity laws, which Yang and Lee postulated. So, why did Chandra do this? This is a question I'm always fascinated by because Chandra himself was an accomplished scientist and he could have easily said, okay, come on, I'm not going to go to the class. Let the students come to me. Why should I drive such a long period of time and such a long distance? No, Chandra did not do that. In fact, jokingly, he told that his whole class got a Nobel Prize. And that is something which is very fascinating to know. Chandra, in an essence, was the epitome of an egoless scientist. He did not see pursuit of science and being a teacher as something superior, but which was something part of a larger ecosystem and community. Now, the question is, are all scholars like Chandra? Do all of them behave that way? Unfortunately, no, they don't. That is an issue here. So, a scholar with knowledge usually has quite a lot of confidence. Sometimes this confidence clashes with the ego, and this ego creates a lot of problem. And there are many interesting examples from the history of science, which I'm going to discuss. First example is, of course, the Isaac Newton. And I'm going to tell you an interesting story related to Isaac Newton's clash with various different researchers. Then Arthur Stanley Eddington, one of the most renowned astronomers of his time, also had an issue. And there is finally Linus Pauling, who was also a celebrated chemist and even went on to win a Nobel Prize in not only chemistry but also in Peace Prize. But he himself had a lot of ego. A person who wins Nobel Prize in peace can also have a lot of problem in finding some kind of a peace, you see. So all three were great scientists, but under certain circumstances, their ego got better of them. And this episode is story about their ego and also related issues related to how ego can perturb progress in science. Let's look at the first story, the clash between Isaac Newton and Robert Hooke. Both were outstanding scientists, extremely reputed people. In 1671 or so, Newton came up with this reflection telescope, which became a sensation during that particular time. In 1672 and 75, Newton published his papers on optics in Royal Society journals, and Robert Hooke criticizes those papers. So Newton obviously is not very happy about that, and he feels that why is this person really criticizing my work and etc etc. And also, really, Newton is a person who doesn't take criticism very easily. So of course, Newton is annoyed because of that particular aspect, and in generally he gets detached from the community of researchers who are performing research within that particular area or in the area associated with that particular research. In late 1670s or so, Robert Hooke and Newton start their correspondence again. This is related to planetary motion, and they are interested in trajectory of particles thrown from a tower. So they are now trying to figure out the trajectory of the particle, and they are trying to hypothesize, come up with theory, and trying to solve this interesting problem. A Hook essentially corrects Newton's answer. Okay, Newton actually gives a particular solution to this problem, but Robert Hooke, during the correspondence, corrects the Newton's answer, telling that there is some particular flaw in this. And again, Newton gets annoyed, and they stop corresponding again. It's quite funny because generally one expects these very big scientists to actually be open to the ideas, but they're really actually having some kind of a petty mindedness in this particular process. So in 1684 or so, Halley, the person whose name is associated with Halley Comet, interacts with Robert Hooke, and Halley is interested in the question of orbital motion. So he's trying to understand the motion of planets and what is the kind of orbits one can actually postulate for the planets, etc., etc. So Hook, who interacts with Halley, tells that the solution to that particular problem is elliptical in nature. Of course, even Kepler gave this particular hypothesis, but he did not give any specific kind of an explanation why it should be elliptical in nature. So, in the same year, Halley also meets Isaac Newton, and Newton also, of course, gives the solution as elliptical in nature. But in this particular situation, Newton elaborates on why that should be an ellipse. And he gives a very interesting kind of theory, and also elaborates on the details of that particular theory. Obviously, Halley is very impressed because Newton was able to solve this particular problem. During this particular period of time, Newton also realizes that he's indeed working on an important problem. So, therefore, he really puts his time and effort in understanding this problem and also expanding on this particular problem. And in 1686, he starts the 9-page paper, which essentially is the seed for the Principia Mathematica, his magnus opus on mechanics, which plays a very critical role going further and literally changing the world of science, because Principia Mathematica is considered as one of the greatest scientific achievements in the history of science. Interestingly, during that particular time, the Royal Society does not have money to publish this magnus opus. Okay, because the previous year or during that particular time, they would have published a book, and there would be no funds to publish it. Of course, then Royal Society also probably would have had limited funds, and this is a very interesting situation. It happens so that Halley, with whom Newton also interacted with, invites Newton to publish his paper in Philosophical Transaction of Royal Society, and the work, which is essentially the seed of the Newton's Principia, gets published in this particular case. Now, after the publication, Robert Hooke gets very furious. He blames Newton of plagiarism because some of the ideas is already floating in the air, so to speak. And Robert Hooke thinks that these ideas which Newton has published mainly kind of originates from some of the correspondence with Robert Hooke had with Isaac Newton. So this causes a lot of clash between these two gentlemen, and it creates a lot of friction between them. And Robert Hooke asks the credit for the inverse square law, because Newton would have hypothesized the inverse square law, and he would have actually taken that particular idea and expanded in this particular publication, which further leads to Principia Mathematica. Newton also reacts very, very kind of weirdly. What he does is he removes all the references from the Principia in which he had referred to Robert Hooke's publication. This is kind of very petty, but you can see that there are two great men who are really, having done enormous amount of work, but still they are really fighting very small children, and sometimes even children don't do that. But it's kind of astonishing to see people like Newton and Hooke really fought with each other. By the way, Newton also had a lot of problem with Leibniz, and the history of science tells that Newton was not a very easy person to work with or interact with, and it is a kind of an unfortunate thing that egos plays such a critical role in these kind of things. Which means that the inference we can draw is ego is detrimental to scientific discourse, and which is not very good, because it really perturbs the way knowledge can progress, And this is one of the unfortunate situations. And there are very good references. For example, The Dawn of Science, written by Padmanabhan, T. Padmanabhan and Vasanthi Padmanabhan, published in 2019, has elaborate kind of exposition on this particular kind of clash between the two people. There's a lot of interesting details about Isaac Newton also. If somebody is interested, I would urge you to have a look at this reference. It's a good read. The next story I want to describe is the clash between astronomers and an astrophysicist, Arthur Stanley Eddington versus Subramaniam Chandrasekhar. Eddington was a great astronomer. In fact, during the kind of peak period, Eddington was considered as probably one of the greatest astronomers in Europe and also across the world, because he also verifies Newton's general theory of relativity through an outstanding observation. And Chandra, like many people, admired Eddington, and he would have been interacting with Eddington for quite some time when he was a student at Cambridge. And during these regular interactions, he would have exchanged ideas. He would have learnt a lot from Eddington also. So in 1935 or so, there is a Royal Astronomical Society meeting in which Chandra presents his complete solution to the stellar equation. And Eddington criticizes Chandra's work. And Chandra is not aware of the fact that Eddington is also speaking in that meeting on very same topic on which Chandra presented his complete solution. So Eddington refuses to accept the limit of the mass of a star, which Chandra would have hypothesized, which is now very famously known as the Chandrasekhar limit. But Eddington is very reluctant to consider Chandra's contribution. So he proposes his own alternative theory, which is not very convincing during that particular time. This particular episode has a very deep impact on Subramaniam Chandrasekhar's work and outlook. It actually changes the way he thinks about science and scientists. And in future, it has a deep implication on how to look at the science itself as a pursuit. Now, during this particular period, Chandra also takes the input from various different scientists. For example, Rosenfeld, Niels Bohr, Wolfgang Pauli, Moeller. So all of them say that Chandra's work is in the right direction, and Eddington's work actually was not correct. But the domination of Eddington in that particular field was so much that nobody was ready to confront him directly. Eddington kept criticizing Chandra. That is very unfortunate. You can see how ego is really coming into the picture here. In fact, he calls Chandra's work at some point of time as stellar buffoonery. Stellar buffoonery. This is the word he uses, unfortunately, to ridicule the work of Subramaniam Chandrasekhar. And it's very unfortunate because Eddington was an outstanding scientist. He did not have to do this, but he was really taking on a novice and a young person who had done some outstanding work. So in 1939, Chandra publishes his complete theory. And of course, a lot of people read it and they clearly see that there is a lot of interesting content in that particular work. And they also clearly see that the Eddington's thought process was not correct for at least in this particular problem. Chandra still admired Eddington, in spite of the fact that Eddington was so rude to him, especially in conferences and other places. He would still interact with Eddington all throughout his life. In fact, during Eddington's birth centenary, Chandra gave lectures in Cambridge University, and the title of the lectures, you know what? Eddington, the most distinguished astrophysicist of his time. Okay, this is the kind of approach Chandrasekhar took, and you can see what approach Arthur Eddington took to really come up with ideas and also confront those ideas scientifically. Unfortunately, ego sometimes masks scientific judgment, and this is a nice example to see how, unfortunately, Eddington really kind of brought in his ego and could not take the point that he was wrong. And this sometimes happens with people with strong views and strong egos. There's also a very nice paper in Physics Today by Kameshwar Wali, who, by the way, is the biographer of Subramaniam Chandrasekhar, in Physics Today, published in 1982. If somebody is interested, I would urge you to have a look at that particular paper. It's very well written, and there's a very long description of this battle between Eddington and Chandrasekhar, and it's worth kind of reading it. The third battle, or so to speak, the clash of ego, comes between Linus Pauling and Dan Shetman. Linus Pauling was a great chemist. His contributions to quantum chemistry and molecular biology is unparalleled. He's considered as one of the greatest chemists to make a connection between quantum mechanics and chemistry, and also very deep insights into molecular structure and the electronic structure of molecules, etc., etc. In fact, he went on to win two Nobel prizes. He actually got a Nobel Prize in chemistry and also for peace, and this is very rare accomplishment. But there is also another person in this particular story, and his name is Dan Shetman, who discovered the quasi crystals. Icosahedral phase is an interesting phase related to quasi crystals, and Dan Shetman makes an observation, and he publishes this particular work, which after some particular kind of opposition. But unfortunately, he has been ridiculed very badly because this did not go according to the convention of the ideas which were prevalent during that particular time. And the leader of this opposition was none other than the great Linus Pauling. Pauling remarked in one particular meeting that there is no such thing as quasi crystals, only quasi scientist. So you can see how badly he was kind of making fun of Dan Shetman's discovery. And there were also other people who got motivated by Linus Pauling and started making comments on Dan Shetman's work. For example, in one of the meetings, somebody told, "Go back and read the textbook." Okay, this is the remark they made. There was another remark made where they called Dan Shetman as a disgrace to his team. This is very strong kind of criticism and very scientific way of looking at things. But you can see these are all people who are not just small people, but they have very super egos, and they're all making comments against a work which is supposed to be scientific in nature. So discourse is supposed to happen in a slightly more cordial way, but unfortunately, no, that is not the case. But the interesting aspect is that Shetman proved them wrong. In fact, so much so that his discovery has stood the test of the time, and it all culminated very well when Dan Shetman got the Nobel Prize in Chemistry in 2011 for the discovery of quasicrystals. That was a very rare story because such kind of opposition by a very big person to an idea, which turns out to be correct, does not get the traction and kind of further support. But in this particular case, it's a very unique thing because Dan Shetman finally got the support of the community, and the community really rewarded him for this outstanding achievement of his. So again, we can infer that ego comes in the path of scientific judgment, even among great people and great scientists like Linus Pauling. So when I talk about these kind of people, Linus Pauling, Eddington, or Newton, these are all excellent scientists. But you can see that there is also a negative aspect related to the way they behaved, which is unfortunate but this happens very prevalently in scholarly environments. There's also very nice references if you somebody is interested in it. There are nice interviews of Dan Chatman where he describes about Linus Pauling's behavior, which is unfortunate, but it's important for us to learn about these things. Now the question arises: why do some scholars become egoistic and narcissist? Okay, this is a question which is just not only occurred to me, but this question has been formally addressed also in scholarly literature. So there is a publication called the Feb's Journal, and Bruno Lemaitre, who is a biologist by the way, has written a nice paper, and the title of the paper, and essentially it's a commentary, and the title of the commentary is "Science, Narcissism, and the Quest for Visibility." And let's see what he has to say. The question is, why do some scholars become narcissists? Okay, he says, quote, there is strong evidence that psychological mechanisms similar to those underlying animal dominance hierarchies are present in our species. It has been proposed that differences in status in humans do not stem from differences in threat or coercion, but rather from differences in the amount of attention, both in terms of quality and quantity, conferred by others. To rise in the hierarchy is to become more visible, or in a word, more popular. So, what he is trying to say is that this is true in the family where brothers and sisters compete for parental attention, sometimes resulting in friction that can endure over a lifetime. Stop quote. So, in this particular case, Bruno is trying to tell that this narcissism and egoism essentially is arising because the people are trying to seek attention, and during that particular process one can falter and make a lot of mistakes because they want to dominate their thought process, and they want to be more visible. And it is a very interesting psychological analysis which people have done, and there's a lot of interesting literature related to this. The same author, Bruno Leitmer, has also written a book, and the title of the book is An Essay on Science and Narcissism. How do high ego personalities drive research in life sciences? It's a very interesting book, and I found some of the discussion to be very fascinating. And there's a lot to learn from this particular book, because it gives you a sociology of how scientists think, and how, as a community, a lot of people do make mistakes. And there's an elaborate discussion on various different points. For example, how narcissism affects scientific practice. He introduces the narcissistic personality in the scientific context itself. He also talks about development and evolutionary roots of narcissism. So he's essentially telling what is the original roots, why is narcissism really occurs in such a kind of situation, and the impact and rise of such kind of behavior on society and science. Because, as you know, science and society always are closely connected to each other. And what are the effects because of such kind of a behavior? It's very beautifully described in this particular book. I would urge you to just have a look at it. There's a fascinating discussion on all these topics. What is interesting is he also describes a very interesting problem with the prizes also in the same book, An Essay on Science and Narcissism. So, to quote him, let me tell what is the problem he's talking about Nobel Prizes. Start quote. The Nobel Prize fits with the narcissistic vision of science, peopled by heroes, many of whom are very self centered, but who, of course, can turn into nice and ethical people once they have succeeded. Science requires many different skills, and it is regrettable that recognition often goes to the storytellers or the dominant males of the community. By taking into account the tacit dimension, we could also better highlight the other key roles and skills: experimenters, tool constructors, organizers of database, that hugely contribute to the progress of science. Stop quote. Now, what inference can we draw from this particular thing? You can see that history of science shows that intellectual rivalries are very common. In fact, we just discussed a sample, but there are many other cases in which such kind of problem does arise, and that's very unfortunate. Along science is objective, the pursuit of science has subjective elements to this. So this is an important aspect because we all think that doing science is extremely objective in nature, but no, there is a lot of human element related to this, and one will have to also factor in when one is looking at the sociology of science in this sense. Science mainly is a collective enterprise. This is sometimes it doesn't get really much emphasis because most of the time people get awards, as the author just mentioned, and there's a lot of attention given to people who have already got awards or people who have done some very interesting work. Maybe they actually have done some interesting work, but that has been done in a collective environment. And this is something which we have to always remember, that science is a collective enterprise. And the lone genius viewpoint is essentially flawed, because somebody working in total isolation without the help of the community suddenly coming up with something outstanding, it makes a very nice movie. But unfortunately, in reality, science is not that done way. So that is something which we should be very cognizant about. So the community does play a very significant role in pursuit of science. This we have to always emphasize, and this is something which we should never forget while doing science. We need to appreciate it as both as scholars and as society. It is not enough that we as scholars kind of know about this, but the society should also be aware of the fact that science is a collective endeavor. So the room for ego is not much, and one should not give overemphasis to kind of only individuals, because knowledge is built up bottom up, so to speak, because there's collectively a lot of people who would have contributed to building up. And many a times the person who really is working at the forefront and at the peak gets the emphasis, but a lot of people would have also contributed in forming that particular mountain, and one should not only just see the peak of the mountain. So the ultimate kind of inference is, we should let go the ego. That is the main inference of this particular episode. Let go the ego, because the lessons from the history of science clearly tells that if really ego plays a critical role, then it curtails the progress of science, and it also curtails the progress of a human being. And this is something which we have to keep in mind, because it leads to conflicts, it leads to unnecessary kind of disturbance in terms of how one does science. It also leads to a lot of problems in mental health, and this is something which we should be cognizant about, and we should always be very careful while looking at this particular pursuit of science. And therefore there should not be a room for ego. And importantly, humility should play a very critical role in doing science, because that is the best way to learn something. And therefore history of science tells us that there are many repeated mistakes which have happened, but one should avoid making such mistakes. That is the most important motive behind this particular podcast, so to speak. Now, let me end the episode with a poem which I wrote roughly about 15 years ago. Yes, don't be surprised. I used to write poetry long time ago, and the title of that particular poem is called as "Humbled," and it goes the following way: Thrive, thrive, and thrive. Humans vociferously resonate, enslaved to conquer and survive. Their thoughts ignite to detonate. They herald a belligerent tone to unveil the encrypted nature. Oporousness fractures any stone to construct a magnanimous future. Their freedom is in flight, a flight to reach infinity, but they fail to reach despite their enthralled capability. They thrive again and fail, but never give up the pursuit. They wipe their tears and hail to rejuvenate the dispute. If only sapiens could fly, Their covetousness ceases to be bounded. So nature humbles their supply to keep the humans grounded. This is a poem I wrote roughly about 2009, and it is part of my old blog. If somebody is interested, go to Astitva, and you can look at the poem called Humbled. I've also kind of displayed in the visual medium a very beautiful kind of illustrative photograph of Robert and Shane Park Harrison, where he's trying to actually recreate this image where a person is tying up his hands to flying birds, and is looking at whether he can also fly. But unfortunately, he is still grounded. And this is kind of a great metaphor for this humility what a human being has to have in order to actually progress as both a culture and as a society. It's important that we know that we live in a collective environment. So this is Pratidhvani, where we try to humanize science. I hope you enjoyed this particular episode. And if you're interested, please also check out our YouTube channel, which is called as Science Meets History, which is also housed with the Pratidhvani episodes. So you can also check out the episodes of Pratidhvani on this particular YouTube channel. We are, of course, on YouTube, Spotify, Google Podcast, Apple Podcast, and various different platforms. Specifically, the solo podcast is generally what I create. It will be both in the audio and the visual format, and therefore you can also watch the episode and also hear to the episodes. So therefore, and this is exclusively for the solo podcasts. And please remember that all the content what I create is open access and non-commercial, and this is something I am very particular about. And because of the fact that the progression of science and scientific thinking is very important, and what better way to propagate this particular thought process than kind of look into this history of science, which is one of my favorite topics of research also. So you can also check out a lot of other content on my blog, which is called as backscattering, and you'll also check out the content what we create. All the things what I generally post on various different platforms are also posted on my blog. So please check them out, and I hope you will enjoy the content, whatever is discussed in the part of the podcast or on the videos or on the blogs. So this is Pratidhvani, where we try to humanize science with GV Pawan Kumar. Bye bye.